Hey, 8th graders, starting us out with a shout out again. This shout out is going to Kevin. He did an awesome job yesterday in Youth Run NOLA and finished the challenge, which ended up getting him a lot of points in his paycheck and running one lap in under 4 minutes and 30 seconds. So, a huge shout out to you. All right, what we're going to do today is we are going to review how to add and subtract exponents in scientific notation. So, let's start off. First thing I want to do is look at my problem. I have 2 and 34 hundredths times 10 to the third plus 6 and 8 tenths times 10 to the third. So the first thing that I want to do is identify what operation are we doing. We are doing addition. So I need to think, are there any quick tricks that I can do for addition? No, all the quick tricks we know are for multiplication and division. So what we need to do when we are adding, we need to make sure that our base and our exponents are the same. So take a look at our two bases and exponents. Are they the same? Is the exponent the same? It is 3 on both of them, so yes, it is the same. And we know that when it's the same, then we can just go ahead and add our first numbers. So let's make sure that we have our decimal points lined up. First thing I'm going to do is draw both those decimal points in. I have 2 and 34 hundredths, and it said we were adding, so it's plus 6 and 8 tenths. And go ahead and add that. I can add a 0 as a placeholder. 4 plus 0 is 4. 3 plus 8 is 11. Carry the 1. 1 plus 2 is 3. Plus 6 is 9. And again, that decimal point is going to line up perfectly with my other decimal points. So now I have 9 and 14 hundredths. And because my exponents were the same, this is times 10 to the third power. The last thing that we want to check, is this in scientific notation? We want our numbers, not just saying that they need to be between 1 and 9. They actually need to be between 1 and 0.99999. So bigger than 1 and smaller than 10. Is this number here? Is it bigger than 1? Is this number bigger than 1 and smaller than 10? Yes, it is, so this works, and it is in scientific notation. Let's get to our next problem. The next problem is 6 and 9 tenths times 10 to the negative fifth plus 8 and 2 tenths times 10 to the negative fifth. Now, first thing I want to do is identify what operation am I doing. I am doing addition, so I know that I need to look at my exponents. Are my exponents the same? Yes, they are both negative 5. So I know that I can go ahead and proceed. I'm going to add my numbers together, and I see 2 decimals, so I want to make sure that I'm lining up my decimal points, so I'll draw those in first. 6 and 9 tenths plus 8 and 2 tenths, and we are adding, so let's add them up. 9 plus 2 is 11. 6 plus 1 is 7, plus 8 gives us 15, and that decimal point is going to get lined up perfectly with my other decimal points. So, make some more space. This is 15 and 1 tenth times 10 to the exponent was the same. It was negative 5, so it's times 10 to the negative fifth. I am done, except for what I need to do is check, is this in scientific notation? Does this first number here fall in between 1 and 9? Is it greater than 1 and smaller than 10? No, it is not. It is too big. This is 15 and 1 tenth. So we need to do something about that. This number is too large. So I need to make it so that my number is between 1 and 9. So I'm going to move this decimal point back 1 spot so that it's now between 1 and 9. I'm going to rewrite that 1 and 51 hundredths. And this is times 10 to the, now we got to figure out 10 to what power. So we made this number one place value. This became one place value smaller. It went from 15 to 1.5. So we made this one place value smaller. If I make this one place value smaller, what do I need to do with my exponent? Well, in order to keep it balanced, I need to make my exponent one place value larger. So here's where we want to be careful. What is one place value larger than negative 5? It's a little tricky because we're working with a negative exponent. One place value larger than negative 5 is negative 4. So now I can change this to 10 to the negative fourth. We can remind ourselves real quick with a number line. we know if we have -1, -2, -3, -4, and -5, that -4 is closer to 0, or it's one spot larger. All right, our last example. This one is 234,000 plus 4 and 5/10 times 10 to the 5th. So whenever I'm solving an equation, I want both of my numbers to be in scientific notation. So I'm going to go ahead and do that now. I want my number to be between 1 and 9, so I will add my decimal point between the 2 and the 3. Now I have to see how many times I have 2 and 34 hundredths. And I want to see what that is times 10 to what power. So I go 1, 2, 3, 4, 5. I moved it over 5 place values, so it's 10 to the 5th power. So now I have 2 and 34 hundredths times 10 to the 5th plus 4 and 5/10 times 10 to the 5th. I want to look, what operation am I doing? I am adding. So I know that when I add, what needs to be true is that my exponents need to be the same. Are my exponents the same? Yes, they are. So I can go ahead and add my numbers together. I'm going to make sure that my decimal points are lined up. 2 and 34 hundredths plus 4 and 5/10. And add a 0 as a placeholder. That's 4, 8, decimal point 6, and my decimal points are lined up. So I now have 6 and 84 hundredths times 10. What was my place value, or what was my exponent, sorry? I had a 5 and a 5, so this is 10 to the 5th power. I am done. Last thing I want to check, is this in scientific notation? Does this number fall between 1 and 9? Yes, it does, so that is my final answer. You have the rest of your worksheet to do, and then bring up with you. Good luck.